As the question says, a car is going at a speed of 21.6 kilometers per hour when it encounters a 12.8 meter long slope of angle 30 degrees. The friction coefficient between the road and the tire is 1 by 2 root 3. Show that no matter how hard the driver applies the brakes, the car will reach the bottom with a speed greater than 36 kilometers per hour. Let us first discuss this problem. In this question, this car is going to descend this slope, and we all know that as the driver goes on pressing the brakes, that is going to apply more the force on brakes, the speed with which this car will reach the bottom of this slope will keep on reducing. But we need to prove that reduced speed cannot go beyond 36 kilometers per hour. That is, this is the minimum speed with which the car will reach the bottom. So let us first work with the limiting case only. That is, if we consider the car over here as a block, we can say an mg force is acting in the downward direction with a component of mg sine theta along the slope in downward direction and mg cos theta in perpendicular direction where theta is 30 degrees. Now we are having a normal reaction in the upward direction while a frictional force is acting upwards with an acceleration a along the wedge in downward direction. Framing the equations, we can say that normal reaction is equals to mg cos theta. Since there is no acceleration in the perpendicular direction, in the direction along the wedge, we can say that mass into acceleration equals to mg sine theta minus frictional force, and frictional force is equals to mu mg cos theta. Now we have been given that the car was going at a speed of 21.6 kilometers per hour. That is, the initial velocity is 6 meter per second. The slope is 12.8 meters long. That is, the displacement is 12.8 meters. Angle is 30 degrees. That is, theta is equals to 30 degrees. The friction coefficient is, that is, mu equals to 1 by 2 root 3. And also we have been given g equals to 10. So this equation reduces to mass into acceleration equal to mg sine 30 degrees minus mu mg cos 30 degrees. Cancelling the factor of mass from both the sides, we can easily get acceleration equals to 2.5 meter per second square. Now we have the acceleration, we have the initial velocity s, and we need to find out the v. So let us apply the third equation of motion, because there is no role of time here, and third equation of motion is the only among the three equations which has no variable t, that is time. So twice of as equals to v square minus u square, twice of acceleration, that is 2.5, the displacement s, which is 12.8, v square, which we need to find out, and u square, which is 36. So v square comes out to be under root 36 plus, that is 64 whole square, that is v comes out to be under root 36 plus 64, that is 10 meter per second. Converting into kilometers per hour, we get it as 36 kilometer per hour. Now we have the velocity 36 kilometers per hour at the limiting case, that is when the frictional force is actually maximum, that is mu n. Now, since the frictional force cannot increase further, since this cannot increase further, this acceleration cannot decrease further. That is, the acceleration cannot be less than 2.5. And if acceleration cannot reduce further, then if this cannot reduce further in this equation, then obviously this velocity cannot reduce further. And so this is the minimum velocity with which the car will approach the bottom of this slope.